Well, what you're doing in order to make that work, and what you end up doing in supervised learning and function approximation in general, is you make some fundamental assumptions about the world, right? You decide that you have a well-behaved function that is consistent with the data that you're getting, and with that, you're able to generalize. And in fact, that is the fundamental problem in machine learning. It is generalization. Now, what's behind all of this, I'm going to claim, Michael, you jump in whenever you disagree, is...
I disagree. Oh, sorry, too soon. Go ahead.
Is bias. And in particular, inductive bias.
Inductive bias.
Right. So all of machine learning, or certainly supervised learning, is about induction as opposed to deduction.
I see. Induction, of course, being the problem of going from examples to a more general rule.
Right. Specifics to generalities. By contrast, deduction is...
would be the opposite. It would be going from a general rule to specific instances, basically like reasoning.
Right, and in fact, a lot of AI in the beginning was about deductive reasoning, about logic programming, those sorts of things, where you have certain rules and you deduce only those things that follow immediately from those rules. So for example, you'd have something like A implies B, that's a rule in the universe, and then I tell you A. So if you know A implies B is a rule in the universe, and I tell you A, then you also know
that A implies B.
And therefore you can infer that
B.
B. You have A implies B, you have A, that implies B.
Okay.
Is what we just said.
That's deduction.
That's deduction. But what we just did was not deduction before then when I asked you 1, 1, 2, 4, 3, 9, 4, 16, and so on and so forth.
Right.
We did induction.
That was induction.
Induction is more about, did the sun rise yesterday?
Yes.
Did the sun rise the day before that?
Yes.
Did the sun rise the day before that?
I slept in.
Did the sun rise the day before that?
Yes.
Yes. So the sun has risen every day. Is the sun going to rise tomorrow?
I sure hope so.
We all hope so, and we all act like it does, because if it doesn't, then there are a whole bunch of other things we ought to be doing besides sitting in this studio and having this interview.
I think we should warn the plants.
I don't think the plants are going to care.
They are. They really need sun.
I think we all need sun, Michael.
Yeah.
So the idea there is induction is crucial, and the inductive bias is crucial. We'll talk about all this in the course.
Okay.
But that's kind of a fundamental notion behind supervised learning and machine learning in general.
I agree with that, yeah.
All right, so we're on the same page. So that's supervised learning. Supervised learning, you can talk about it in these high muckety-muck ways, but at the end of the day, it's function approximation. It's figuring out how to take a bunch of training examples and come in with some function that generalizes beyond the data that you've seen.
So why wouldn't you call it function induction then?
Because someone said supervised learning first. Well, there is
No, sorry. You said supervised learning is function approximation, and I want to say, why don't you say supervised learning is function induction?
As opposed to function approximation?
Yeah.
Okay, it's
approximate function induction.
Or induction of approximate
functions.
Something like that, yeah.
You don't want to induce an approximate function, you want to induce the actual function.
Yeah, but sometimes you can't.
Yeah.
Because sometimes you think it's quadratic, but it's not.
I have that as a plaque on my wall.
You do?
No.
Yeah, I didn't think so. Okay, so that's supervised learning.